I wish you a wonderful day and welcome to the OXL YouTube channel. In this video we will talk about how we can match traffic in our NFTables rule set. We will talk about matching multiple layer 4 protocols in one rule, using DNS resolved variables, matching by interfaces, ICMPv4, ICMPv6, IPv4, IPv6, user group matching, and how we can mark traffic. Okay, let's get into it. Here we are back on our demo environment, on our firewall. In the last videos we have already configured a very basic rule set, as seen here. If you need to know more, check out those videos. Yeah, now at first we will check out how to match multiple layer 4 protocols at once with one rule. We can do so by using the meta tag. In this case, meta L4 proto, and after that an array or a set of layer 4 protocols we want to match. If we use this way of matching layer 4 protocols, we have to add a TH before the destination port. In this case, we allow network time protocol traffic here. The IPs are static for now. Okay, works. It is valid. I got the IPs used in that NTP allow rule using a DNS lookup. So, can we just use the DNS record itself in our NFTables rule? Let's test it out and check what happens. Yeah, let's validate the configuration and we see an error. Hostname resolves to multiple addresses. This is a major issue with the DNS resolution functionality that is built into NFTables. If the target DNS record does not resolve or resolves to more than one IP address, so one IPv4 and or one IPv6 address, it results in a syntax error. As DNS records are pretty dynamic and most of the time we do not even control those DNS records that we need to use in our rule set, this is pretty much unusable for now. I'm not sure, I haven't found any good information on if this behavior will change in the future, but for now we need to fix it some other way. In my case, I use a script, an add-on for NFTables that generates a dynamic variable file that resolves some host name or host names to a variable. Link is down in the description below if you're interested. I'll also link the video once it's up. As mentioned, if we use a DNS record that resolves to exactly one IP address, it would work, but I personally would still not recommend using it, because if the DNS record gets deleted or is misconfigured, has multiple addresses, it would result in an invalid firewall configuration. So let's check out how that looks. Now we have a DNS record in there that resolves to exactly one IP address, one IPv4 and 6 address, and that works. But yeah, if you need or want to use that built-in functionality, use it with caution. As we now have added some rules to the output chain, let us just quickly talk about when I personally would recommend that you set the default output policy to drop or reject. I would recommend so if the system that is running NFTables here is either hosting some services that are reachable over the public internet, or the service is located in a critical layer 2 subnet, some management network or something like that, or the system is not behind a network firewall, but directly in some public internet network. Why would I restrict the outbound traffic in those cases? I would do so as attackers, in most cases, if they find or get some exploit on the target system, now in this case we'll take the firewall as an example, they will try to get persistent access using some reverse shell, or do some server-side request forgery to attack other devices in the same network, the same internal network. We can restrict the possibilities of an attacker post-exploitation if we just allow very specific outbound traffic, only the traffic we explicitly need. Of course, this makes the rule set a lot more complicated, and we will in most cases need at least DNS resolved variables, if not even a transparent proxy to filter on application layer. As we have already seen in the last videos, we can match traffic by interface name, by input interface name and output interface name. In this case, we use the complete interface name, low for loopback, as we can see here in IPA. Those are the interface names. NFTables, as far as I have seen, cannot work with interface aliases or alternative names. But what we can do is work with wildcards. When can it be useful to do a wildcard interface matching? This can be especially useful if you have some service running on the system, like a VPN, OpenVPN, WireGuard, IPsec, or have a hypervisor Docker running. In most cases, those services that auto-create interfaces will use some specific prefix, some specific interface prefix. In some cases, you can even define the prefix they should use. In that case, we can match those interfaces by wildcard and redirect that traffic that goes into those interfaces or comes from those interfaces to a specific chain. It can be handy to group some rules that are only relevant for that service into a chain. That makes it a little simpler to understand the rule set and let us organize the rules a little bit better. We will not go into a practical example here, but in the next videos when we will talk about more advanced setups, we will use it. Now let's talk about ICMP, ICMP-v4 and ICMP-v6. Yeah, we have now created two variables to showcase ICMP-v4. First, private networks, the usual IPv4 private networks, and a variable that contains ICMP-v4 types. We could also reference those types by ICMP codes, but I personally like the types better as they are easier to understand and read, of course. We could, of course, block all ICMP-v4 traffic, as it is not really necessary to allow it. Some ICMP types like time exceeded, destination unreachable, parameter problem could be nice to have for troubleshooting, and also if you want to ping a system for troubleshooting reasons, echo reply and echo request could also be useful. Okay, in this example, we add a rule that allows all IPv4 types for our management network and only allows the basic types for all private networks. Now let's take a look at IPv6. Unlike IPv4, if we want to use IPv6, the IPv6 stack, we will need to allow some IPv6 types. We cannot block all IPv6 traffic if we want to use IPv6. Of course, if you do not want to use it, you can block it. Here we have a list of some basic types that we will allow for now. Depending on what services you are running on your system, what's the functionality of your system, you might only need to allow a few of those types, but those are pretty much the basic types, so to say. Also, some of those types could be limited to the hop count. Now let's talk about IPv4 versus IPv6. In NFTables, we have a limitation that in a single rule we can only use IPv4 or IPv6. In case like this city-state invalid drop, where there is no reference on IPv4 or 6, it matches both. But whenever we use an IP data, IP SATA, we can only use IPv4 or 6. In the case that we mix IPv4 and 6, like in this example, we get a syntax error. Cannot resolve hostname, address family, or hostname not supported. Exactly. So they need to be separated. We can also use two completely separate tables, as the table type can be set to IP or IP6 instead of ENET, which we are using here. So we could even completely separate the handling of those two stacks, but of course we would duplicate some rules, but however you like it better, you can do it like that. Okay. How can we create a rule that matches IPv6? In this example, we have a rule that matches an IPv4 address, and the second one matches a IPv6 address. Exactly. We use the IP6 statement for IPv6 addresses. When would I recommend to use IPv6? I personally see the main benefit in using IPv6 if you have some service, some public available service hosted, and want to allow end users to connect over both IPv4 and IPv6 to that service. So you configure a dual stack setup on the system that acts as an endpoint. You can, of course, use IPv6 for your internal networks too, for your clients and so on, but keep in mind that you will most probably need IPv4 and 6 addresses for your clients, as they might need to access some services, some public services that only have IPv4 addresses configured, do not support IPv6. Thus, we will need to configure around double the amount of firewall rules, and it can get a little messy regarding the configuration. Okay, let's take a quick look at user and group matching in NFTables. Which users and groups can we match? We can only match local Linux users and groups. We can also only match those users and groups in traffic that is originating from the local system, as this information is not passed over the network. Here in this example, we will showcase a very simple transparent proxy setup. We have networks that are excluded from the proxy and a user that is actually running the proxy service. Then let us create two firewall rules. The first one to allow HTTP and X traffic to excluded networks, and the second one to allow HTTP and S traffic for the actual proxy service. So only the proxy service is allowed to connect to the internet, so to say. Of course, in a real world transparent proxy setup, we would also need to redirect traffic to the proxy if it's not already processed by the proxy. But a practical example will be showcased later on in another video. Yeah, we can also match by group ID. For that, we can simply change the SKUID to a SKGID, and yeah, that's pretty much it. We have to be aware that the user we are referencing here needs to exist on the system. If the user does not exist, we get a syntax error. So this is important, as it might be a dependency issue for our bootstrap, our setup process, as we might need to create users before provisioning, deploying the firewall config. Yeah. When we check the runtime config, we will also see that the user ID is resolved, so we really see the user ID, not the username as we have configured. Yeah. If the user does not exist, as mentioned, we get a syntax error. Of course, also important to not delete users that are referenced by the firewall. Now at last, let's talk about traffic marking. When would we use traffic marking? Traffic marking can be handy if we need to match complex conditions. We can create rules that set a mark, and we can use that mark as condition for other rules. So in this case, the first rule will be used to set a mark using the meta-mark set action. Marks are integer, so for our example, we will use the meta-mark 1. And in other rules, we could query this mark. We could check if this mark is set on the traffic and only perform an action if that mark is set. So we could match it using the meta-mark 1 in this case. We can also set a mark on the whole connection using the CT mark set action, and of course match traffic using the CT mark query. We can also copy the CT mark to the traffic mark using the meta mark set CT mark. And yeah, that's pretty much it. Okay, that's it for this video. In the next one, we will talk about hooks and chains. If you're interested in NFTables and similar technologies, like, subscribe, watch the playlist, and for now, have a nice day. Servus.